going to discuss one important topic for ICSE class 10 physics, and that one is equilibrium. Okay, so what is equilibrium? So effect of several forces acting on a body is zero. Means suppose in a body lots of forces are acting on it and the net effect of that force is zero. Like suppose this one is one object. Now in this object some forces are acting on this object like F1, F2, F3, F4. Okay, and the net effect of this force means suppose I add all these forces, then it should come zero. So that one is called equilibrium condition. Okay, equilibrium का मतलब होता है कि बॉडी में बहुत सारा फोर्स लग रहा है बट वो बॉडी रेस्ट पोजीशन में है, उस पर कोई भी इफेक्ट प्रोड्यूस नहीं हो रहा है, तो हम लोग बोलेंगे वो किस कंडीशन में है, इक्विलिब्रियम कंडीशन में है. ठीक है, हाँ इक्विलिब्रियम कंडीशन में है. ठीक है, सपोज देयर इज वन ऑब्जेक्ट. ओके, here there is one person who is pushing this object in this direction, and suppose it is applying the force of 10 Newton, and this side also one another boy is there who is also applying the force, and its magnitude is suppose also 10 Newton. Then what will happen, whether this body is going to move or it will be in rest position. So as we have seen that this side there is force, magnitude of force is 10 Newton, and another side also magnitude of force is how much, 10 Newton. Okay, so here two equal and opposite forces are acting on it. Okay, so suppose I take this force as positive and this one as negative, then if we add them, then it will come what, 0. F1 plus F2, 10 minus 10, so it will come what, 0. So that's why we can say that this body is in equilibrium. Okay, now there are two types of equilibrium, so we are going to discuss types of equilibrium. First one is a static equilibrium, and second one is dynamic equilibrium. Okay, as we know that a static means when any object is in rest position. Okay, so that one is the meaning of a static, means body is not moving. Okay, it is in rest position. So when any object is in rest position and the net effect of forces is going to 0, so that equilibrium is called what, a static equilibrium. Suppose this one is one car. Okay, and this car is at, suppose this car is at rest position. Now we know that weight of any object will act downward, so this one is weight of car. So suppose weight of car is 50 Newton. Now we know that opposite to this weight there is one reaction force, and we know that reaction force is always equal to the weight of any object. So reaction force will also 50 Newton. Now in this direction, in horizontal direction, we are not applying any force. Okay, this side also there is no force, this side also there is no force. So as we see that this car is in rest position and the net forces acting on this is 0, means this force is not going to produce any effect. So this type of equilibrium is called a static equilibrium. So static का मतलब क्या होता है, कोई भी ऑब्जेक्ट जब रेस्ट पोजीशन में हो, ठीक है, और उस रेस्ट पोजीशन में जब वो ऑब्जेक्ट है उस टाइम में उस पर जितना भी फोर्स लग रहा है वो सारे फोर्सेस का जो सम होगा वो क्या होगा, 0 होगा. then we can say that that object is in a static equilibrium. Our second one is what? Dynamic equilibrium. Okay, so dynamic means what? When body is in मोशन। ओके, मतलब कोई भी ऑब्जेक्ट जब मोशन में होगा तो उस टाइम में उस पर जितना भी फोर्स लग रहा है, ठीक है, उस फोर्स का जो नेट इफेक्ट होगा वो क्या होगा? जीरो। ठीक है, मतलब बॉडी में कोई भी अनबैलेंस फोर्स नहीं लग रहा है। जैसे कि सपोज दिस वन इज वन एरोप्लेन। ओके, देन दिस एरोप्लेन इज moving. Okay, and we know that aeroplane is in motion, but it is in balance condition. Okay, why it is in balance condition? Suppose there are so many forces are acting on this aeroplane when it is flying. Okay, so let's consider this side there is F1 force, this side there is F2 force. So F1 is equal to F2, and in vertical direction there are two forces, F4 and F3. So for equilibrium condition, F4 and F3 should be also what? Equal. And when we sum these all vertical and horizontal forces, it should become what? Zero. So that one is called dynamic equilibrium. Okay, so dynamic equilibrium का मतलब है कोई बॉडी अगर मोशन में है, ठीक है, और मोशन में होने के बावजूद भी वो किस कंडीशन में है? इक्विलिब्रियम कंडीशन है, मतलब उस पर जितना भी फोर्स लग रहा है उस फोर्स का नेट इफेक्ट क्या होगा? जीरो। ओके, सो दैट वन इज कॉल्ड डायनामिक इक्विलिब्रियम। Okay, now let's discuss about the before let's discuss clockwise and anti-clockwise movement. Okay, so previously I have discussed you that what is movement. Okay, here I am going to discuss what is clockwise movement and anti-clockwise movement. Now suppose this one is one seesaw. Okay, and this seesaw is hinged at this point. This one is called hinged point. So it is hinged at its center. Now one person is standing here and there is one another person who is standing here. Okay, let's suppose this person has weight 50 Newton and this person has weight 40 Newton, and this distance is 5 meter. This side also this distance is 5 meter. Okay, so total length of seesaw is 10 meter. Okay, and in middle we have hinged it, hinge support. So hinge support means what? देखो, the hinge support is only not allowing translation motion, means ये जो सीसो है ये इस डायरेक्शन में कभी भी मोशन नहीं होगा, ना ही अप डाउन होगा, ठीक है, ना ही हॉरिजॉन्टल मोशन होगा, ना ही वर्टिकल मोशन होगा, ठीक है, बट इसका जो रोटेशनल मोशन है वो हो सकता है। समझ में? सो दैट वन इज कॉल्ड हिंज सपोर्ट। जैसे हम लोग के विंडो में या डोर में हम लोग सपोर्ट देने के लिए उसको लगाते हैं ना, जिसके अबाउट वो डोर रोटेट होता है। ओके, सो दैट वन इज कॉल्ड हिंज सपोर्ट। ओके, उसमें बस रोटेशन अलाउ होता है, वर्टिकल मूवमेंट या हॉरिजॉन्टल मूवमेंट अलाउ नहीं होता है, ठीक है। सो दैट वन इज कॉल्ड हिंज्ड मूवमेंट। नाउ सपोज हम ये जो पर्सन ए है और ये जो पर्सन बी है, ठीक है, इन दोनों का मोमेंट निकालेंगे किस पॉइंट के अबाउट? जहाँ से ये रोटेशन हो रहा है। सो दिस वन इज रोटेटिंग पॉइंट ओ। So we have to find out the moment about this point O for this person B and person A. So let's take first consider for this one as F1 and consider this one as F2. Okay, So let's find moment m1, moment due to force F1. So we know that what is the formula for moment? Force into perpendicular distance. Take this one as d1 and this distance as d2. So F1 is how much? 50 Newton into this distance is how much? 5 meter. So it will come how much? 250 Newton meter. This one is clockwise or anti-clockwise? See, this force try to rotate this seesaw in this direction. Okay, so it will try to rotate in this direction. So this direction is what? Clockwise. Now find the moment due to force F2. So we know that formula for moment, force into perpendicular distance. So here force is F2 and distance is d2. So our F2 is how much? 40 Newton into our distance is 5 meter. So it will come 200 Newton meter. And this one is anti-clockwise. So anti-clockwise we can write like this, counter clockwise. Okay. So this one is called clockwise moment and anti-clockwise moment. Now suppose let's take another example. Suppose this one is one rod or bar. Okay, let's say bar. Okay, iron bar. And this iron bar is hinged at this point. This one is also hinged, not fixed. Okay, it this bar is able to oscillate like this in this direction. So that's why it is called hinged. Okay. Now in this bar, suppose one force F1 is acting and that magnitude of this force is 10 Newton in this direction. Okay, one another force 5 Newton, okay, which is acting at the middle of this bar, and let us take this distance as 5 meter and this distance is also 5 meter, and there is one another force that one is 6 Newton which is acting in this direction, and this distance is 7 meter. Now again let's find the clockwise moment and anti-clockwise moment producing on this system. So tell me first which force is going to produce clockwise moment and which force is going to produce anti-clockwise moment. So see, this F1 force, this force will try to rotate this bar in this direction. Okay, so this one is which direction? Anti-clockwise. Okay, now let's see this force will also try to rotate in this direction. So this one is also anti-clockwise moment, and there is one another force 6 Newton force. This force try to rotate this whole arrangement in this direction. Okay, so this one is which direction? Clockwise. So let's take first m1. M1 means moment of force F1. So F1 into d1. You should remember that we have to take this distance from the axis of rotation. Okay, so F1 is 10 Newton. Then this distance d1 is what? We have to take distance up to here. Okay, because this one is our axis of rotation. So 5 and 5, it will 10 meter. So it will come 100 Newton meter. Now again find the moment due to force F2. So this one is our F2. So F2 is equal, M2 is equal to F2 into D2. F2 is 5 Newton into distance is 5 meters. So it will come 25 Newton meter. This one is counterclockwise. This one is also anti-clockwise or counterclockwise. Now take force F3. This one is force F3. That one is 6 Newton. So find the moment produced due to this force F3. So F3 into D3. And F3 is how much? 6 Newton into, again we have to take distance. So this distance is how much? From axis of rotation perpendicular distance is 7 meter. So it is 42 Newton meter and it is acting clockwise. Now let's find the total clockwise moment or total moment. Okay. So whenever in question they will ask you find total moment. So total moment M will be equal to sum of clockwise moment plus sum of counterclockwise moment. So this one is called total moment. So let's take M is will be equal to clockwise moment is which one? M1 and M2 is, oh sorry, M3 is clockwise moment. So write down M3 plus anti-clockwise moment is M1 plus M2. These both are what? Counterclockwise moment or anti-clockwise moment. So this one is total moment. Now in this case, suppose I have to find total moment. So M3 is clockwise. You should remember that in your book, in class 10 book, it has said that we have to take anti-clockwise moment as negative and clockwise moment as negative. So we can take clockwise moment as negative minus 42 and anti-clockwise as positive. So anti-clockwise moment is 125. So minus 42 plus 125. So how much it will come? So 3 8 83 Newton meter. Here it has come in positive sign. Okay, so this positive sign indicate that the overall rotation of this system will be what? Clockwise or anti-clockwise? It will be anti-clockwise or counterclockwise, because have you seen that now this counterclockwise movement is more as compared to clockwise movement. Okay, so it is going to rotate in counterclockwise movement. So one note you have to make that clockwise moment we have to take negative. Okay, in your book, okay, it is not necessary that you can take always negative. You have to remember that suppose you have taken clockwise as negative, then take anti-clockwise as positive, or suppose you have taken anti-clockwise as negative, then clockwise as positive. But for your classes in your book, we have to consider that clockwise moment negative and anti-clockwise moment as positive. Okay, so what I have discussed that first, equilibrium. Okay, equilibrium means when several forces are acting on an object and there is no effect of that forces on that body. Okay, means वो body rest position में ही रहेगा, then we can say that that body is in equilibrium. Then we have discussed types of equilibrium: static equilibrium, dynamic equilibrium. Static equilibrium means when any object is at rest position, okay, and the effect of all the forces is going to be zero. So that one is called a static equilibrium. Dynamic equilibrium means when several forces or the effect of forces acting on a body is zero when it is in motion. So that one is called dynamic equilibrium. Then we have discussed clockwise moment and anti-clockwise moment, and I have told you that which moment we have to take negative and positive. Now let's discuss one important topic. That one is principle of moment. Okay, no. Before that, let's discuss one topic. That one is condition for a body to be in equilibrium condition. Okay, so what are the condition? On that we can say that that body is in equilibrium condition. Okay, so there are two conditions. First one is sum of all forces. Sum of all forces, and all forces means what? जो फोर्स हॉरिजॉन्टल लग रहा है, हॉरिजॉन्टल एंड वर्टिकल फोर्स. ओके, सम ऑफ ऑल फोर्सेस जिसमें हॉरिजॉन्टल एंड वर्टिकल फोर्सेस should be 0, or we can write like that. Summation of FH means horizontal force is equal to 0. Then summation of FV means vertical force is equal to 0. Okay, so this one is first condition. Like suppose there is one object. In this object, suppose 10 Newton force is acting downward and 50 Newton force is acting upward. Okay, and in this side there is force of 5 Newton, and this side also there is force of 5 Newton. So tell me whether this object is in equilibrium condition or not. So let's find first summation of vertical force. So vertical force means there are two forces which is acting on it, 10 Newton downward and 50 Newton upward. Let's take downward moment as positive and upward downward force as positive and upward force as negative. We can take any sign. Okay, don't confuse with it. Suppose I take this one, this upward force as positive, then I have to take this force as negative. Okay, because force is vector quantity and we require magnitude and direction. So magnitude we know that 50 Newton, but is directing upward. So one side we have to consider positive and another side we have to consider negative. Okay, so let's take this one as positive, minus 50 Newton I have taken negative, and plus 10 Newton I have taken positive. So it will come as minus 40 Newton. So as you seen that now you are seeing that the sum of vertical forces is not going to 0. It is not equal to 0. So vertically it is not in equilibrium. Okay, now let's check sum of horizontal forces. So horizontal forces, this 5 Newton and this one is 5 Newton. Suppose take this one as positive and this one as negative. So 5 minus 5, it has came what? 0. Okay, so in horizontal direction it has came 0. Okay, but in vertical direction it hasn't come, it is not 0. So we can say that this body is not in equilibrium. Okay, for equilibrium the horizontal force as well as vertical force, it should be 0. Means horizontally it should be in equilibrium and vertically also it should be in equilibrium. Okay, so sum of horizontal forces is going to be 0 and sum of vertical forces is also going to be 0. Then we can say that any object is in equilibrium. So this one is first condition, sum of all forces should be 0. Algebraic sum of all forces should be 0. Now second condition is what? Algebraic sum of moment. Okay, it is clockwise and anti-clockwise. You should remember that. Algebraic sum of moments about axis of rotation or some point. Okay, about axis of rotation should be 0. Okay, so moment is also going to be 0. So what is the meaning of that? Sum of moment, when sum of moment is going to 0, when clockwise moment will be equal to anti-clockwise moment. Okay, then we can say that algebraic sum of moment is going to be 0. So this one is the two condition. Okay, sum of forces is going to be 0, and algebraic sum of moment is also going to be 0. In our syllabus, in our for 10th class, this is going to be used. Okay, always you have to check moment, clockwise moment, whether clockwise moment is equal to anti-clockwise moment or clockwise moment is not equal to anti-clockwise moment. When this will happen, we can say that the body is in equilibrium condition. Okay, now let's discuss principle of moment. So principle of moment, according to principle of moment, when an object is in equilibrium condition, then sum of clockwise moment is going to be equal to sum of anti-clockwise moment. So this one is principle of moment, and this principle of moment is very important for ICSE board class 10. Okay, because they will ask lots of questions from this principle of moment. This principle of moment is used to find weight of unknown object. Okay, I will tell you through numericals how we are going to find the weight of unknown object. Okay, let's take one example. Suppose this one is our meter rule. Meter rule means whenever in question they will write meter rule, so you should understand that this one is one rule, meter rule. Okay, whose total length is how much? 100 centimeter. Okay, so this one is one scale. Okay, whose length is what? 100 centimeter. Now in question it has said that this meter rule is hinged or supported at mark 40 centimeter. What is the meaning of this? The scale in which there is 40 centimeter mark. Okay, in that point we have given one support, hinge support. Okay, and one object is placed at 10 centimeter mark on this scale or meter rule. Okay, and they have given the mass of scale is equal to 5 kg. Okay, this scale, total mass of this scale is how much? 5 kg, and we have to find the mass, or sorry, weight of this object A, which I have placed now. So we have to find the weight of this object. So how we are going to find the weight of this object? Okay, so where in question it has written that this whole system, okay, this whole system is in which condition? इक्विलिब्रियम कंडीशन. ओके, सो ये मेंशन किया हो रहेगा क्वेश्चन में. ठीक है, ये लिखा हुआ रहेगा कि जो मेरा सिस्टम है दिया हुआ वो किस कंडीशन में है? इक्विलिब्रियम कंडीशन में. मतलब इसमें किधर भी रोटेशन नहीं हो रहा, ये ऐसी हॉरिजॉन्टली रेस्ट किया हुआ है. ठीक है, नाउ लेट्स सॉल्व दिस क्वेश्चन. ओके, so this one is a scale, and we know that for any meter scale, suppose this one is 1 meter scale, this total length is how much? 100 centimeter. So its middle point will be lie at where? 50 centimeter. Okay, so 50 centimeter is what? Center of this scale, and we know that for regular shape object its center will lie at the middle point. Okay, and this point, there is one point in which its weight is acting, means we are considering that whole weight of this object is going to act at this point, and this point is called what? Center of gravity. So for regular shape object, its center of gravity will be what? At center. Okay, suppose this one is रोड, ठीक है, अगर इस रोड का लेंथ 50 सेंटीमीटर है तो इसका सेंटर कहाँ होगा? 25 सेंटीमीटर लेंथ पे. ओके, सो ये 25 सेंटीमीटर होगा. यहाँ पे इस पॉइंट पे इसका वेट क्या हम लोग कंसीडर करेंगे? एक्ट कर रहा है. सो दिस वन इज कॉल्ड सेंटर ऑफ ग्रेविटी. ठीक है, सो वी हैव टू know these things. Now let's, this weight is acting, this weight is acting, a scale weight is acting at this point. Okay, and they have given this weight, this weight they haven't given, they have given mass. Okay, so weight is equal to, we know that weight, what is the formula for weight? M into G. So M is how much? 5 into G, we have to take 10, so it will come what? 50 Newton. So 50 Newton is the weight of this scale. Okay, and we don't know the weight of this object, so consider weight of this object is what? W. Okay, now this one is, this point is our axis of rotation, so we have to take all the distance from this point. Okay, so let's find the moment of this weight of the scale and moment of this weight of the object. Okay, and this one is our axis of rotation. So as already it has mentioned that in question it is in equilibrium condition, so by principle of equilibrium we can write that sum of clockwise moment will be equal to sum of counterclockwise moment. Okay, so clockwise moment, first identify that which one is clockwise moment, which will produce clockwise moment. This weight of this scale, okay, it is going to rotate this scale in this direction like this. Okay, so it is going to produce clockwise moment. Okay, so force, we know that moment, what is the formula for moment? Force into distance. So 50 Newton is force into distance is this distance we have to take. So this distance is how much? This one is marked as 40 centimeter and here it is marked as 50 centimeter. So distance is how much? 10 centimeter into sum of counterclockwise moment. So counterclockwise moment, only one force is acting, okay, which is producing which moment? Counterclockwise moment. So this force is going to create moment about this direction, मतलब ये एंटी क्लॉकवाइज रोटेट कराएगा इस ऑब्जेक्ट जो होल अरेंजमेंट है उसको. ठीक है, सो फोर्स यहाँ पे हमको नहीं पता है, सो वी कैन टेक W and distance, this distance we have to take, okay, from rotating point, sorry, up to this. So this distance we have to take. So this distance how much? Here 10 centimeter mark and here 40 centimeter mark. So in between that distance is how much? 30 centimeter. So 10 and 30, this is going to cut. So W will be equal to 50 by 3. So this one is the weight of this object, unknown object. Okay, so this one is the application of principle of moment. Okay.